Hey there, welcome back. So today, finally, I have decided we'll be starting with the code. So first, I will tell you what I have thought. So okay, we are not going to be using not going to be making bin free list because I think we should first implement this. Uh, Wait, okay, sorry. So this is the easy static implementation. This is a free list with just so the blocks of memory just point to the next free block of memory. So that is it. We'll be first making this. Just to get started, I don't think we should directly jump into bin free list because I looked at what are how is the free blocks maintained in current implementations TC malloc or uh, what are what are some names like RBP malloc or J malloc or some other stuff. So it's pretty complicated AVL trees or red black trees and whatnot. So they also use binary sorry not they use bind they use bins too, but for larger memory blocks they use trees and all. But I think we'll move on to that. We'll be first implementing this, a simple free list of static size blocks. It is the most simple thing. It will use it will use first fit algorithm. And yeah, I think even if I'm saying it is like a simple implementation, it will still take a lot of efforts for me, but at least it will get me started. So also we'll not be implementing coalescing yet. We'll implement coalescing into this. So let me tell you the stages what we are going to work on. So first, implementation of a simple free list, then coalescing will be added to this. I know, I understand coalescing is difficult. I have some idea of how I will do it. I haven't looked up how usually they do it, but yeah, something this I don't even like. I know I read about buddy system somewhere, uh, but yeah, I'll look into it. I was just writing down stuff. I don't know what it means. So yeah, so let's start implementing, I guess. Okay, so I'm not sure whether okay. So even if I have said we'll be implementing this today, but I'm not sure. I think a majority of our time will go into uh, understanding what all do I have to do and all. But yeah, let's go ahead. Uh, and uh, I guess I have to say first I was stuck. Like even in the previous video you must have known, I said I'll be implementing the bin free list because those are more common and nowadays used. But I forgot that the title of this video is not like a senior C++ developer of 20 years of experience in system programming making a memory allocator. It is Noob making a memory allocator. I'm a total noob. I should start with simpler projects. So yeah, I guess I can still okay. I can still do it, but yeah, let's keep the pace a little bit easy. Wait, what was is oh yeah, yeah. It's 1200. Yeah, 1199. Let's go. Let's go. Not stop recording. Okay, 4 minutes in and we haven't done anything. That's fine. No problem. Is this okay? Yeah. So as you can see, this is our alloc. Yesterday we uh, git cloned it. Oh yeah, I have to clean this. Git status. I have made a commit of our previous the assembly fix, changes to the assembly code. So it was not. Nah, just watch the previous video. I'm not going to explain. It's fine. Okay, so let's get started. So we have to make Also I have to like take a look at what validator.h has. It's 200 lines long. Okay, I will look at it afterwards. So and then allocator.c, let's go. So we have to start, so not check, we have to start from my init. Here we'll see like this is the initial size that we want. Then my malloc, this is a basic implementation, which is just calling mem as brk every single time it wants memory and not really like optimizing and all. Void free, we have to also implement free. So to like the, as you can, so this diagram will basically be implementing this. Where is it? Yeah, we'll basically be implementing these two codes. So let's get started. So first what I have to do is like, I think I have to like break down. First I have to like take a look at trace files. So yeah, and then let's start with short traces. Yeah, short traces is fine. So short traces. So first, my first concern is like, if we are making statically sized blocks, what should the block size be? So I need like what is the maximum blocks used by the like inside the trace files. I should know that, right? So okay, so I can say 4072. Next, oh I should, yeah, 4072 is the, wait, what? Yeah, traces. Okay, I know there must be like some kind of like okay, should I try that? G. Oh, okay. So okay, if I do this s slash, I have to find for every a with a space, and it ends over here with a number. How do we say number? Is it this? What? I don't remember. Okay, let's just do manually. 4072, 4072. Okay. Oh, I see a 8008. Okay. Okie dokie. Wait, what was the 8 stuff? I think I lost it. This must be painful. 8208. So it's like, I think it's a multiple of 8. Is it? Let's check. So 4072 is indeed a multiple of 8. So we can like the alignment issue is, we won't have any alignment issues in the free list that we are going to implement. So it's no big deal. And 4072 into 2 must be 8144. So not that. 807 8208 8208 divided by 8. It is indeed a multiple of 8. So okay. Okie dokie. I hope there isn't a number 4072 4072. Oh man, we are going to be allocating like a 8000 bytes long block just for a 72 byte value. That's going to be brutal, but okay, that's fine. It's fine. It's fine. $4,000. I don't see anything anything greater than 8,000. So that is good. Oh, I see a 10,000. Okay, I think I should like okay, 10,000. Let's just do one thing. Let's just keep that ambiguous for a second. So first, let's get over here. So what do we have what do we have over here? So first in my malloc, I guess in my initialize we'll do something. So we don't want to be like allocating okay, but what will we do? So in my initialize, I have to like allocate a very contiguous initially I have to like call mem_sbrk. So void initial uh, initials block, you can say. This will call mem_sbrk, and I will call it for size of, I'll define the values above. So this must be like, I'll define it. Okay, let's define it over here. So inish, not here. Okay, I cannot just use like static and stuff. Okay, so I'll just declare it over here. Anyone, this is not a good way to like, okay, no, I shouldn't. Let's follow the standard. Okay, so hash define first initial number of blocks. I'll keep it 100. Initial number of blocks, num blocks as 100. I hope there isn't any num blocks out there. Yeah. Okay, initial number of blocks is 100. Then static size, that's what you fixed size, yeah. Fixed size of blocks is, let's give it 10,000 for now. Let's make it 20,000. Something divisible by 8. 20,000 is, yes, 20,000 is indeed. So let's make it 20,000. So 20,000 size of block, 20,000. Okay, so we have defined number of block, num block is 100, fixed size of blocks is 20,000. Okay, wait, let's search for block size 2. I think there might be, I think we saw it in previous videos. No, that's not. Okay, that's good. Block size, yeah. So now we have num block and block size. So we'll allocate that many bytes of memory, you can say. So wait, size is a size tree. Okay, I don't think that matters. Yeah, we'll indeed call it with the starting of a line. Yeah. As like they have done the stuff. Yeah, and I think we shouldn't be calling like directly. So int, not align size. So even if, wait. So what they are doing is align. No, it's not for that. Okay. Let's just get over with. So mem_sbrk is int align size of what can we say? Num block and block size. Yeah, so num block times block size. That's great. So we get an initial pointer. we are like allocating. So now wait, that's like okay, 20,000 bytes into 100. uh, what is that like, duh, 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 2 million, yeah, 2 MB of size. That's great, right? Okay, that's fine. It must be fine. Okay, let's go. Let's go. Cool, cool. So first, initially we get. Oh, also I forgot to consider one more thing. So we have to also allocate the size for like each. You can say each pointer that is in that is present inside the block. Not inside the block, but between two blocks. You can say. So the pointer will have its own size, and the pointer should be initialized with a null pointer. Okay, so we'll also initialize one with free free block. Okay, free block. Okay, got it. Okay. Okay, so I forgot to consider that. So if you are allocating 100 blocks, we have to allocate roughly, how much is that? One pointer to a, it's like 64, it's 8 bytes, right? A pointer in C. No, I guess it's system like architecture based, but it must be 8 bytes. Let me just confirm. So pointer size in C, a 64-bit system. Yeah, size of pointers, it must be 8 bytes. Yeah, so 8 bytes, so 100 blocks, and for them we have 8 bytes, so block size is 20,000. We will also be allocating 8, so I won't just like write this, so I will also add another thing. So size of a pointer, size of free pointer. Yeah, that's great. Hashtag define PTR size So one more thing I have like noticed, like the my keyboard typing, the sound is like crazy. Like it sounds like I'm like bashing my keyboard in, but it's not. Like I might be. Okay. So yeah, this is 8. So let's go over here. MSBRK plus not number of block, but yeah, I guess number of block plus, sorry, into number of block times PTR size. That's great. So now we have initial pointer, so we have to also say like whatever the pointer we have, we have to give it to like the initial stuff must be what we can say. We store the size of the block we have allocated in the first place. Oh, that's okay. Okay. I forgot one more thing. We have to also. No, I guess we do know the size, so it's not a big issue. Okay. So let's just get started. So return 0. So wait, I have to like, okay, let's fine. So nvim memlib.c mem, I have to like consider like the exceptions. So void pointer, return old brk, and if there was an error, return void pointer -1, which is -1, right? void pointer, so there wasn't anything. -1 previous. Okay, okay. Hmm. If there was an error, what is going to be returned by this thing? It's a null, it's a void pointer, but what is it pointing to? What might it be? What might it be? Let's see. Significance of void asterisk -1. So on success SBRK returns the, if the break was increased and the is returned, then the error number is then this value is pointed to the start of the dedicated memory. On the error void star -1 is returned and error number is set to unknown member, whatever. The significance of what is the exact memory address it points to, if it does at all. How is it guaranteed that void is not a valid address that can be returned by this BRK? Yeah, that's what my concern is. So it's 0x on the 32-bit machines or 0 machines are invalid address that is supposed to be bigger than any other address. Okay. So I have to like just check. So okay, I hope the future me is going to laugh at this code, but yeah, if initial block is equal to void, sorry, not this, void -1 return -1, and I guess that's it. Yeah, printf. What do they use for errors? Fprintf, yeah. Fprintf stood error. I guess if there was an error, no, I don't think I will have to like do it. Memlib already handles that for us, indeed. So okay, that's great. So initial block is memsbrk. So now we have like those things. So now we have to make a free list. So initially for 20,000 blocks, for int I is equal to 0 till I is less than, not, come on, I should be using I, J, K and L. Okay, so we are 23 minutes in and we have wrote like first line of code, but I guess it will improve, it's fine. So initial SBRK, mem SBRK can be allocated. Okay, so now we have initial block, we are getting the memory. Now we have to add like the first free block pointer inside that. So first so this pointer that we have got for the initial block, so as we can see over here, the p value memsbrk, yeah. Oops, an error. They too did it. See, I think we need to do it. So okay, yeah, wait, we do have to do it. So if initial block is equal to void pointer -1 f printf stood, or just we can just do return null. Null, okay. Null is an integer, yeah. So next we'll write, so that was a success, and okay. So now we have, what do we have? So now we have to, why am I like blanking out? So okay, we store the size of the block, we allocated the first size t size bytes, okay, and then we return void pointer. Then we return a pointer to the rest of the block of memory, which is at least size bytes long. Void star char star p, okay, plus size t size. Got it. So we'll write over here for int I. This is like just the beginner code. I'm not going to. Just going to like check if it works. If it doesn't, it's fine. It's not fine. I'm not going to use like I, J, and L. Okay. So now num blocks. For how many blocks do we have to do it? And I plus plus. So what am I going to do? I should be like moving the pointer ahead, but I should be keeping the start. So free. Yeah. So okay, let's do one thing. So void star free. I hope the free is not present anywhere. The free name, free pointer, my free. Yeah, I still should do it like free pointer. Void my free pointer points to the initial block, and for every number of block, what we are going to do is we are going to man, I'm blacking out. Okay, so star, we are going to allocate not star, this is asterisk. Yeah, size t p, okay. So we store size t bytes of memory into that. So this is supposed to be a pointer, so pointer has 8 bytes, so pointer size is equal to pointer to the next. So it should be storing the next blocks. That is a big concern. So okay. Void pointer next block must be the current block, initial block, plus, wait, I'll reference it. So yeah, so current block plus current block plus so current block plus pointer size, pointer size. So initial block plus pointer size plus number of block, so block size. So this is the next block. So now I will allocate, I'll just add comments. I'll just keep on adding comments. So storing the initial free pointer. Okay. Creating a free list for creating a free list. That's fine. So next block is, so void next block is pointer size plus, yeah, so storing the address of next block, then we'll add, so what is like the pointer size? Yeah, pointer size pointer size pointer size dereferenced, right? Yeah, pointer size dereference of the initial block is equal to, like, we are writing that stuff onto it, so we are writing the value of next block onto it, writing the address of next block on the current pointer. Is it supposed to be like that? This is fine, right? I think that there are a lot of problems over here, but I'm just going to like write, this is just syntax, so I'm just writing what my mind is thinking, and I will think about syntax later on. Okay, so I have written the value of next block onto it, and now my pointer should move forward. So initial block, start block, should I name it? I shouldn't have named it initial block, you know. Okay, current block, I think I should, not current block. Yeah, let's do it. Which helps in creating the list, free list. Okay, so void star current block is equal to initial block, current block so okay, now we have written over it. So now we have to move the current block by some number of steps. So current block is equal to current block plus ptr size plus, or okay, or I can just do star current block is equal to, wait, void star next block is like a pointer to the next block, right? Yeah. What am I doing? I'm not understanding anything. Okay, current block is equal to next block now. Okay. Now let me think. So what has happened? We are going to iterate for those many number of blocks, and next block, the pointer of next block is equal to dereferenced current block. Okay. Should I try this? Yeah. Let's try this. Okay. So I'm going to make like nvim temp.c, has to include stdio.h int let's introduce the sbrk function. So yeah, this is great. Sorry, here I think we do need to import like some stuff. I just do all of it. Config.h, this is fine. Yeah, okay. So now I will let's say unsigned unsigned int increment is equal to 100. So I'll call void pointer current is equal to mem sbrk, and I will send an increment to it. I'll just return 0, and I will printf percentage p. Oh, I want percentage d. Wait, percentage p slash n current pointer value, and printf. I don't think it has like an integer value, just okay, because it looks like it's not necessarily an integer, you know. So I think there must be an error while doing this, but yeah, let's see. So clang temp.c and an error out. Mem.sbrk, okay. Mem.brk, what? Yeah, first of all, mem.brk, wait, what is it asking for? And then temp.c. If mem.brk plus got it. This is what they're asking for. Static cast on mem.brk, but I'll just use like sbrk in this. sbrk increment plus equals increment. I'm a special grade user. The initializer must run first. sbrk, yeah, it's fine. We'll just copy all of this. And I'll define I'll just copy it. Wait, what is it? Max heap value, right? So rg max heap nvim config.h line number 36. We take it, move it, boom. Okay, so yeah, also the init function, which is over here. Okay, so I don't think init function is asking for anything extra. Start brk, mem brk, mem max address. Okay. This should work. Okay, let's try again. Let's go. So it worked. It's just my tomfoolery, not tomfoolery. What is it called? My shenanigans. Okay. Wait, what? Mem heap size, printf. Warning, there's an error to understand mem heap size. ISO and later do not suppress function declarations. Okay. Yeah, fine. We'll just remove that. So nvim temp.c. Then max heap size. So max heap size, we don't have that function. Is that why that's happening? So rg max. Wait, how does it look? Max heap size here. max heap size. Wait, we don't have that. Seriously? Wait, no. Yeah, got it. So it's inside, what is it? memlib.c, yeah. Max heap. Mem heap size. Oh, it was like mem heap size. Yeah, this is mem heap size. Yeah. So error name is block field, ran out of memory, 0 pointer value. Okay, so this is the pointer value. Pointer value points to whatever. So what if you try to like make difference? Yeah, okay. Ran out of memory. Why did we get the ran out of memory over here, right? Content c.c. Mem is block field. Mem is block plus increment is greater than mem max address. Oh, we didn't call mem initialize, right? Mem initialize. It's mem initialize void. Okay, we'll call mem initialize first. So mem init. So okay, that's what I wanted. Yep, we have a working thing. So so I'm getting the pointer value as 0x13. So this must be like the correct value. So when we are trying to print the pointer value, so we are getting that thing. So pointer, what if I reference like what if I try to do this? It's a void thing. So what is like the void equivalent for it? So okay, how to print how to print pointer value in C. So percentage %d is supposed to be for integers, I guess. Yeah, p slash, sorry, the value of s is okay. So this is like the value. Wait, okay. They did something different. So s is asd. Okay. I was trying to understand something with pointer, so I wrote this code. Let's see. I don't need to use the shortcut cats t. I still don't understand what does two pointer like two asterisks mean, but okay. I think I'll skip this one and let's go for something easier, which is geeks for geeks. So okay. So percentage %d, yeah, exactly percentage %d. I don't want percentage %d. I want something different. So printf percentage %zu. Zu is supposed to be zu is supposed to be for size. So okay, null pointer, void pointer. Yeah, that's what I wanted. How to? Okay. Just a minute, guys. Just a minute. I'll be back in just a minute. I'm back. So okay, 46 minutes in and we haven't done anything. Why is it like? Why is it this? Why is like this case every time? Like, I just waste a lot of time, I guess. Oh no, I didn't waste time. Okay, I've done like this much stuff. I'm trying to figure out stuff and okay, let's get okay. So pointer size current. Okay. So let me understand this. So wait. Okay. So void. So next block points to should point to the current block. So I shouldn't be doing this, right? But I cannot add a pointer with a integer. So in some way I have to dereference it. So dereferencing void pointer. What does that do? Dereference a void pointer. I will also open geeks for geeks, for my dumb brain. So int, okay, lvptr is equal to instar lvm. It doesn't make sense to difference a void pointer. How will the compiler interpret the memory that the pointer is pointing to? You need to cast the pointer to a proper type first. Got it. What if it's holding an address? What if yeah, that's correct. Wait, how are these guys doing it? So wait, plus size t. So they're rightly doing it. See, they are. Oh, they are like okay, got it. Wait. I'll just copy this for like a minute over here. So okay, so what they are doing is they are casting a void pointer again. So what they are doing is the initial char star p. Okay, so they are casting a char pointer to p plus size t, and then and then returning the next address. Okay, but why is my malloc returning that? So initial. Wait, I'm so confused right now. Okay. So void next block is pointing to current block. So wait. So I should be dereferencing it correctly, which is char star is like for each byte, right? Is that fair? That's fair. Wait. I need to understand this clearly again. Okay. Pointers are confusing. Like, damn. Okay. This is clear what I wanted to do. So pointer size will block size. This is cool. So current block. So this is the current block. It will be initially pointing to the starting address of the memory address, like memory block that we initially allocate here, and we will next block should point to that. So what they are trying to do over here is they are trying to cast it into a char pointer and then increase it by that many sizes, because char is like int and stuff, and then recasting it into a void pointer. Am I getting that correct? So we cast that into a char star pointer with a char pointer, we increase the size, and then we point it to void pointer again. Fair? I guess it's fair. Why don't we just do integer then? Right? Why don't we do integer then? So integer size, we cast that into integer. Okay, then we do. But char is like 1 byte, right? I'm so confused. Okay. Let's just keep it char for now, because these guys have done it. but we'll look into it. So okay, then the next thing is pointer size. This should be integer, right? I should keep it like size t, because yeah, it should be a size t pointer. Wait, what is size t size? Size t size. Yeah. Smallest line size that will hold a size t value. Okay. Got it. So okay, so size t pointer is equal to next block, current block is equal to next block. So we write that onto it. But why are we like doing that again? Why are we doing that stuff? Okay, I'm so confused right now. Wait, this is I'm in very confusion, and it's like I have to like switch off my fan, so it's getting hot in here. How many? 52 minutes in already. I'll just wing it. Let's go. And current block is equal to next block if we see an error. So let's test this, what we have written. So here current gives us the void pointer. So if we try to do like, if we want to move the pointer by these many bytes, so we have define for now. So okay, so go here and then we try to increment. So void pointer new one is equal to what we are doing. Let's just do what we are trying to do over here. So this is this, and pass it into char plus what was it? PTR size plus block size. Yeah, PTR size plus block size. Yeah, and just okay. So now stdc out, but printf should show like this /n with current, and the same thing with new one. So let's try this. Yeah, got an error. Expanded from macro PTR size is 8. Not expanded from macro PTR size to match this. Okay. With what char star? Oh, okay. I messed up. Yeah, I messed up over here. Here I wanted to write correct. Char star, yeah, got it. So what's the error? Block size, can't just do warning expression result unused, w unused, block size. To match this, char star current plus block size. Let's try to do integer, expanded from macro PTR size, expected this. Why though? Let's try to cast it into integer then, because all of the other stuff is integer. No. How am I supposed to move the pointer? Should I declare it into a size t? How will I do that? How to do that? How they done? Like align. What is align using? Size T is align size of um, align size rounds up the nearest multiple of alignment. Error expected expression, block size, W unused value. What happens if we like cast it into CAD star? Let's first look into that. Yeah. Okay. So okay, let's uncomment this one. Let's move it above, and let's see void. No, void. Is there auto? Okay, then mustn't be. So let's say CAD star new one is equal to CAD star current. Okay, and then I try to do this printf %c %p. Let's first do %p, and this will point to new one, and here we'll do %c and then dereference this one. So let's see this. Yeah, okay, that's working. And since we don't have anything over here, this is fine. So what if I do this new, so CAD star pointer. So what if I do this CAD star new one is equal to a okay, wait, how am I supposed to add that into it? So we are supposed to add using size T and just add size directly. Okay, got it. So I'll first dereference this. That's what they did. Dereference what size you want to add that in. So I want to add char size. So dereference to char star new one. New one is already that, and that is equal to a. So if I do this, this should show something. We have it, boys. We have done it. We haven't done like everything, but okay. We have done some stuff. We have accomplished at least something. That's great. It must be difficult for you guys. Like, this must be over here. 59 minutes in, 1 hour in, but okay, it's fine. You haven't even completed one function. Okay, it's fine. In the initial time, like for I guess 1 or 2, not 1 or 2, maybe for the initial few days, we are going to have some problem in the speed of making this project, but it's fine. And later on, I'll get like decent momentum, and that will be fine. So okay, so we have new one is equal to a. So we have done this. So if we want to allocate, so first we need to dereference it. So what I wanted to do over here is I have to dereference, and this still should be a void pointer. So void pointer current block should be equal to, I have to like move the pointer one step ahead. So how are we supposed to do that? Let's figure out that one. That is important too. So I guess I understand this. So let's figure out this one. So if you want to move it by one step ahead, so what we'll do is, what can we do? GC, not new one. Let's give it another name. Temp. Yeah. So void start temp will point to, it will be a void pointer. It will point to it should be like current plus pointer size plus block size. That's very easy. Why isn't it doing that, you might be asking? So that is because this should be size t, difference value of size t, I guess, size of nah man. So I have a pointer current. How to move void pointer? How to add how to increment memory pointer? How to increment memory pointer? Want to increment the pointer address? Yeah, it's fine to Google that, right? Int star p, int a is equal to 100, p is equal to address of a, and what will the following code actually do and how? Okay, I know this kind of messy in terms of coding, but I want to know what will happen when we code this. Let's assume the address is a is equal to 502, it is stored in pointer p, whose address is now what will be the value of p and a, where the execution of each statement. Okay. First, plus plus operation takes precedence over the star operator, and the basis operator. Pointer moves to the next in position as if it was an array. Okay. Wait. It moves to the next position. PTR is a that's p plus plus. Okay, so p is a void pointer. So void pointer plus plus should be 1. But no, in our case it's a void one. It's not integer one. If it's integer plus plus, okay. Pointer moves to the next in position as if it was an array. The value pointed by pointer is incremented. Yeah, that's fine. Value pointed, it's the same thing. Pointer moves to the next in position as if it was an array, but returns the old content. Pointer is the value pointed. The pointer moves to the next in position as if it was an array. So as if it was an array. One could do memory void pointer. Memory void pointer. Now let's write that. Increment void pointer by 1 byte. This is what I wanted. So void star char plus plus. So see, that's what they were trying. So char star pointer, they increment that by plus plus, so it moves by 1 byte. That's what they're trying to do. Could I do something like please okay. I have a void pointer called PTR. I want to increment this value by a number of bytes. Is there a way to do this? Please note that I want to do this in place without creating any more variables. Could I do something like PTR void pointer? PTR is casted into a char pointer. We increment plus plus, so it moves by 1 byte ahead, which is the size of char ahead, and then we cast it again into void pointer. You cannot perform arithmetic operation of void pointer because arithmetic is defined in terms of the size of pointed to object. You can, however, cast the pointer to a char pointer, do arithmetic on that pointer, and then convert it back to void pointer. So void star p is equal to static assert char star p plus 1, p char star p plus 1 in C. Okay, got it. Plus 1. Okay. Wait, what? Okay. So that's what we are trying to do here. Why is it working then? So this is supposed to be a char pointer. Media size, block size, this is supposed to be end, right? Why isn't it working then? So current is converted to a char pointer. Let's try this one. Let's say this. Let's try this one. You know, we never know. Yeah, it worked. It moved by 1 bytes. Let's go. Be doing an improvement. Let's go. And if I add PTR size, then PTR size, unexpected day before day. Okay, it isn't allowing a macro. Why is that though? Pointer size 8. Why is that? Is it because of like size t. Am I supposed to like write here size t? Size t. What if I do this? No, the same thing. So it's allowing me to do this. Plus, I guess it will also allow me to do this one. Yeah, it did allow me to do that. So, okay, strange behavior. What if I do an int pointer? Wait, temp.c. Why isn't it allowing me to do that? So what if I cast it into an int pointer, because I guess that is what is happening. So okay, int pointer, then ptr size, int pointer, it becomes an int, and then semicolon. No, we don't want it to be an int though. We want it to be a single block. Expander macro, ptr size, expander macro. Let's search for let's just search for why is this happening. Okay, unexpected day before day. Okay. Let's look at why this error usually occurs. So C note expansion a macro. Okay, expansion macro is using there. Okay. Expression macro put into 32. I have hundreds of warnings like this when build with GCC. I assume you're using Clang. When Clang detects an error on a warning in code expanded from a macro, it outputs one line for each macro whose expansion leads to the offending code. Fix the errors and warnings in the final code and these messages will disappear. Oh, wow. That's crazy. Iterative advisor have most warnings and they finding warnings is generally a bad way of dealing with them. They are there for a reason. This is not a warning. Okay, this is a warning though. Void star pointer cast star ptr size before the expected a semicolon. I don't get it. Wait, is it working though? So if I do this, let's try this. So I'll comment this out. Yeah, this is working. And if I go over here and if I write printf %d and I do ptr size, what's going to happen? Yeah, there was an error. Ah, I got it. It's because of semicolons. It's because of semicolons, guys. It's because of semicolons. This is it. Come on. This is it. High five. High five. Come on. Let's go. Give me a high five. Give me a high five. Let's go. Let's go. Let's go. It was because of a high five. And if I do this plus num size, wait, what? Num block size, sorry, my bad. Yeah. Wait, I should just do this. Block size, sorry. Block size. Let's go. Let's go. Let's go. Yeah, feeling good. Okay, let's go. Void star pointer pointing to this. We add the next block. So this is done, and then we write that into. This is already this, so we don't need to wait. But how? There's no point in dereferencing the void pointer, right? So what are we supposed to do? Okay. So this is already a void pointer. We dereference it, and then next block, and then current block is. So now current block is equal to next block. Hmm. This should work, right? This looks decent. There must be no errors. There must be no errors in this, boy. Okay. So mem initialize. Let's copy this entirely. Move it to our temp.c, which is working, which is shocking too. And we will call myInit. This is my int answer is equal to my init. Wait, if myInit, if it fails, what are we supposed to do? If it fails, we'll find out eventually. Yeah. So myInit. So initial boxes. Yeah. The 64th line. Yeah. 64th line, 44th. Yeah. Okay, so ISO 9 does not allow indirection on operand of point. Yeah. Okay, so we cannot dereference a void pointer. So we can just do this. So we are not supposed to do this line. Not this one, but this line. So we are not supposed to dereference a pointer. So current block will directly point to next block. We'll just directly move the pointer. Wait, inside the current block, we'll go by current block is equal to next block. What if I want that to be like only that particular size? You're getting me, right? So here they have specifically mentioned like what size they want to write it in, or is it not needed? I guess it's not needed. We store the size of the block we have allocated in the first size t bytes. Size t bytes. Okay. Start B. Let's try this anyway. Current block, next block, and then current block. Next block we do have, so current block, we write that into next block. What happens over here? Let's see. Current -1. That's fine. We aren't printing anything, right? So here we'll try to print like, okay, so current block, how should we go ahead with this? So let's, okay. myInit, so let's do this. Okay, so now we will try to do this. So printf %b current block, yeah, and then printf %b/n next block. Let's try this, shall we? Okay, there should be a difference of 4E8C. Okay, so first we initially got like an address of 64. So what is the hex difference between this? Hex difference between these two should be around 20,000 plus 8. Okay, let's hex to wait hex arithmetic. Why convert stuff? The hex calculator is doing the same thing. 4E8C. Oh, I wanted to paste. Okay, since we are going over here, let's paste this over here. And this will be minus. Calculate. Okay. The first number need to contain 0 or 9 and EF only. Okay. E C. The second number need to contain 0 to 9 or okay. It is working. It is indeed working. Let's go. Let's go. Let's go. Let's go. Okay. So we indeed. So wait. This still isn't confirmed. Like, is it working and all? So wait. How many minutes are we in? 1 minute 70 seconds. Should we end here? Because I think this is like a good ending. Yeah. Wait. I'm not sure though. Okay. So what we did was m.c. So what we did was we got a pointer for the initial block. We pasted the current block. Okay. So okay. Next block is a pointer to what it's supposed to be. We have to check, is it printing like what we want. So when current block is equal to next block, yeah, I understand the main concern. Let's try that. This is the main thing. Okay, this is going to be the main thing. Sorry, there's no one over there. I don't know why I was looking there. So void star is previous block. Previous block is equal to current block. Okay. After the current block has, like, after this operation, there should be the pointer of next block in there. So you getting me? So I have to. We can't dereference it though, right? How am I supposed to like confirm that? How am I supposed to confirm that? Okay. You guys must be so confused. So let me tell you what I'm thinking. Where is my marker? So I do have my marker over here. Where is my duster? It's not necessarily a duster. Okay. Just give me a minute. Going out of the frame. Okay. I'm really impressed by what I'm doing over here because I am not using ChatGPT and just figuring out stuff, and yeah, this is going great, I guess. Yeah, I'm just figuring out stuff, and that's great. Okay, so what we are doing over here, let me just confirm this. So yeah, so we have, I should show you guys. Yes, this is it. Let me increase the screen size. Yeah. So what's happening is that, so let's consider this as the block. So when we initially call mem sbrk, we are getting a pointer. Yeah, we are getting a pointer over here. So mem sbrk, the initial block, the variable that we called initial block. So what I want to do is I want to break this memory into number of blocks. The num block variable, which we set to 100. So let's say I want to break this into 100 blocks. Yeah, fairly. Dot, dot, dot. Okay. So if it's broken into 100 blocks, I want to do another thing. This is successfully. This is working, I guess you can say. Or are we just iterating? Yeah, so this is my main concept. This is what I want. So out of this, you can say this block, this is this part of it. So this is one block, by the way. Okay, just to show, this is entirely a one block. This is one block. This is another block. This is next one, and so on. So this is the pointer. This is the free pointer, the initial, the free pointer. This free pointer, I want to initialize. So my init function, what I want to do, I want to initialize this free pointer, and I want to create a free list inside the initialize function. So this is the next block pointer. This is the next one. This is the next one. So what I'm trying to do is that I want to copy this pointer here, so I can point this, and this will then point to this, and this will then point to this. This is what I want. I want to somehow copy the address of this pointer. Ooh, I get it. I want to copy the address of that pointer. I want to copy the address of that pointer. Sorry, I want to copy the address of that pointer. I want that address. Wait, am I figuring out some stuff, or am I like... So this is the free pointer that we get. This is a void star pointer. So this is void star. This is a void pointer. This is a void pointer. Okay. Void pointer, and this is an address which we get from char star current plus ptr plus block. Okay, so this is supposed to be a hex thing. It's a pointer value. It's still... I'm not supposed to confirm this. So one thing that we can say for sure is that we are definitely like traversing this array, but I'm not sure how to confirm, like, is 1199 1199. Yeah, so I'm pretty sure we are traversing the linked list correctly, but I want to like make sure that we are storing the next block, like the next address, onto like the current I'm so dumb. So I want to store address of this block inside over here. If I want to store address by my, I think this is, let's just try this one. So I have something in my mind. Let's try that one. Let's try this. Okay. So we are inside tim.c. We are okay. So we are over here. So this is basic traversing. Writing the address of, yeah. This is what we want to do. This is what we are trying to do. So previous block, current block. Yeah. Let's check this. Okay. So current block is equal to next block. This is done. So current block is done. So if we printf point inner value of a previous block. We'll also like say this is a previous one. The previous block. Why? Oh yeah, I messed up the spelling. Where did it go? Yeah, the previous value is, yeah, the previous is 4EC, that's correct. Previous is 314, that's correct. Previous is 13C, that's correct. I'm trying to read what? How to read that? How? Let's end the video, I guess. Yeah, let's end it. Oh shoot, I am totally screwed. Okay, so let's end the video. We are still okay, even if we are trying for something better, we are still ending this on a really great note. Even if this is the last stream of the 3 consecutive days that I'm going to do, I'm still hyped for the next whenever we will try to do it. uh, yeah, I'm still hyped. So yeah, thanks for watching. I'm Aditya Bachwane and I'm an engineer for fun. Bye.